So I wanted to run through a quick um, data modeler primer for this next bit. Many of you have already got experience in data modeling, and many of you have either taken a class from me or from other people who've sort of talked about this. But this is, I mean, honestly, it's meant to be sort of a primer, high level, and how you know I would do data modeling in this course anyway. So what I did is I'm up here in trying to get you guys basically a free tool. Now, admittedly, some of you, if you wanted to, you could certainly use Visio for this, or you can use some other kind of product for this. But I wanted to show you a little bit about data modeling in sort of a case environment. Not implying the other ones aren't, but anyway. So what I did here is basically I literally did actually a Google search, I believe, for Oracle Data Modeler download, and it brought me to this. I clicked onto the download. It did get me to log in, but I logged in on a non-Oracle account, and I was able to download Data Modeler. From there, I basically went out to, not to chapter 9, but I went out to my C drive, and I've got it sitting right here. What I typically do with Oracle products, because they've got so many version numbers and whatever, is I tend to copy the name into my folder just in case, sorry, the name of the version into my clipboard. And then I'm going to double click and I'm going to extract and go. And I don't think this takes as long. If it does, I will probably pause the video. And as if by magic, it's finished. All right, so sitting here, I've got myself my C drive. When I unzipped it, by the way, when I extracted it, it created a folder right under C, in this case, called Data Modeler. You would expand that, you'd go down and you see, hey, look, there's Data Modeler executable. I generally create a quick shortcut of that executable, and what I tend to do is rename that shortcut the actual version name. All right. You know, because I do this long term, of course, I keep track of the versions I'm in. Many of you might not care. You'll just basically bring it up, do the assignment, and then bail out. That's totally cool too. All right, so now what I'm going to do is I'm going to start this up for the first time. So I'm going to start up, and it's going to, you know, crawl its way along. It is likely going to ask me the question about whether or not I should I should be importing settings from a previous version. And there it is. It's all of a sudden asking for that. Now notice, very bad user interface question here. I can't say yes. I only have one option, which is no. So I don't know why it didn't just let me go. But if I did have a previous version, I'd basically say yes or no. All right, so then off it goes, and it isn't that long. It took me about 8 minutes to download. It took me probably about maybe 2 to 3 minutes to unzip, and now it's taking me who knows how long now to just get going. Now, one thing I will do at this point is I will shut down that website. I don't need to be there anymore. Okay. So here it is. So it comes up with this. It says, hey, do you want them to basically track you? Now, you know what? You can say yes. You can say no. If you're a long-term user, I'd suggest go ahead. But because you're not, I'd click on uncheck that box. Again, this is modal. You can't do anything until you've clicked on OK. Why don't you go ahead and expand it, get yourself the maximum there, and then none of the models we're doing are going to be large enough to really justify the navigator. Sometimes you have a model that's like multi-pages long. This is really awesome, but for now, I don't care, so I'm going to get rid of it. Messages, we don't really care about. For now, we're going to get rid of it. And then the other thing we're going to do is going to go File and Close All, and that'll get rid of this pane. And now we're basically where we want to be. We want to be basically with the logical and the relational. Put your focus on the logical first. You'll remember in systems analysis, we have the logical part, and then we actually have the design part. So we're actually going to kind of do both at once here. And one other thing, a quick cleanup. The startup page isn't totally useless. I would definitely, if you're interested in doing some of this more later, I would consider looking at that. But for now, I'd get rid of it. You can always find the startup page again, by the way, under help. All right, so here we go. Let's model the classic example of students and their courses. It's a classic example, and I think many of you have probably seen this already, but I just want you to sort of see this in the context of this particular tool. So in the logical phase, we're dealing with entities. In the relational or more physical phase, we're dealing with tables. We're going to go logical first because I'm trying to get you guys to think in the terms of design up to the more technical design. So what I'm going to do here is there's a little button here. It looks like a box maybe with a wheel in front of it. That is basically the entity, and you can see that when I move my mouse over top of it, it keeps the new entity. It's called a tooltip. Pops up. I'm going to click on that. Nothing looks like it happens, but all of a sudden now my mouse has become a cross and like a target in a rifle. So now if I basically take my mouse and move it over any part of the white space here, and I can go, and what it does is it brings up a dialogue. And this dialogue at this point, I'm going to call student. Okay. And at this point, I'm going to go OK. Now, the other thing that we're trying to figure out is how about student and courses? So I'm going to click over here, and we're going to go and call it course. And you know what? I am going to pluralize this. I'm going to call that courses. I'm going to call this students. Any real militant data modeler will quickly point out that you shouldn't do that. These should be the singular of the instances, but I'm making them the plural. All right. Now, we need to know stuff about students. What do we need to track? Well, what we probably need is we're going to go to, sorry, let me do this a bit slower. You can re-enter the wizard by double-clicking on the entity. And then really, most of this other stuff you won't need because this is more of a primer. And then we can go to attributes. Attributes are things that describe a student. When you think about things that describe a student, you think that probably every student should have a last name. I'm going to just call it last name. Okay, every student should have a last name. What else should a student have? Every student should have a first name, and so on. Every student should have an address. And at this point, I'm just going to go full address, but you would want to really break that up a little bit. So I'm going to go full address, and I'll just put in my comments, need to break this down. Okay. And another thing that students typically have is they have a GPA, we'll say. Okay, so we get that. There is some students. What do we have in courses? Courses also have attributes. They typically have a course name. They typically have a faculty that they're assigned to. And another thing the course would likely have is they'd have the amount of credits. Okay, so that's pretty cool. And let's zoom in a little bit to make this a little bit more pleasing. So we got ourselves our two entities. Now, we're not even close to being done yet, but let's just focus a little bit on this. What these O means, these means that these are optional. These are optional. Now, we would have to make a decision. What are optional and what's not? If we re-enter the students and we look at the attributes, we're going to say that the full name is, or the last name is mandatory. The first name is mandatory. The full address is mandatory. We need to know where the students live, but maybe they don't even have a GPA yet because they just started. Now I'm going to go apply, and you can see the change that happens here. Right? All of a sudden, these things become asterisks, and this becomes optional. Now we do the same thing for courses. I go over here for courses, and I say, well, the course is certainly going to have a name. It's going to have a faculty. And actually, I honestly think they'll probably have to have credits. So I'm making these decisions, let's move this over, making these decisions as to what is optional and what is mandatory. All right, so that's cool. What else do we have to do here? Well, the thing is, if we really want to move this to completion, we have to start saying, what is a last name? What's its data type? Now, in this tool for now, just trust me that you're going to go to logical and then pick from the various options down here under logical. Domain does make sense. I'm a little sad it's the default because it's not as common. Logical is basically every bit of data type that came in with the tool, And domain is types that you can create, right? So, but I would think if I design this tool, I'll put logical first. Now, when we're looking at this, you're going to see some stuff that's going to be kind of similar. Like you'll see, for example, oh, I don't even see it. I'm not sure why I don't see it. But anyway, okay, so integer, and I think maybe down here, small int and all that. Anyway, Oracle doesn't have an integer data type. It has a number data type. But the thing is, this tool was meant to be used by not just Oracle people, but by SQL Server people, by IBM people, by other relational databases. You could even, in theory, use this with Access. So, so that's why there's so many different options. Now, I was an Oracle guy, so I'm going to go ahead. I'm going to go and call this thing a varchar, variable length character. That's ANSI standard, by the way. ANSI being ANSI, American National Standards Institute. So I'm going to pick an ANSI standard data type, and I'm going to basically say this guy can be up to 30 characters. Awesome. First name, also going to go logical. Going to go down, make it a varchar, and give it 30 characters. Awesome. Full address. Again, I wince when I'm doing this, but whatever. I'm just going to make it a varchar, make it 100. So varchar basically means variable length character. That means that if the address is only really 5 characters long, it's only going to store 5 characters. It won't store 5 characters and 25 spaces. So varchar is typically what you use for stuff like that. And if it's more fixed length, like for example, Social Security would be probably 334 plus the 2 dashes. So that's 12. So, all right, no, am I right about that? I think I'm right about that. Yes, that's 12. So then I'd make that maybe a character 12. Why character? Because the dashes are more characters. They're not numerics. Anyways, GPA is not going to be a varchar. We're going to make that numerical in this case. And a GPA typically goes from slightly above 4 if you're really smart to 0. So what I'm going to do here is I'm going to say it's numeric. It's going to have, I'm going to allow 3 numbers of which 2 are decimal. This means that the largest GPA would be 9.99. The lowest it could be is 0.01. All right, that's what that means. I'm going to go OK. Now it doesn't look like anything happened, but if you double click, it definitely is aware of data types now. Versus over here, when you double click on this, it's not aware of data types. Let's do the same quick exercise with the courses. So let's go varchar, make you a 30. Basically just going to go make you a 30, and oops, didn't mean to go out of that. Make you a 30, and make you a 30. Oh, I'm losing my mind here. All right, make you a 30, and we'll make the credit. What is that? Credits. That's going to be also, I think, a 3, 2. So let's just go OK to that one. Make you logical. Make you numeric. And make you a 3, 2. All right. Now we double click back in there. We'll see that. By the way, if you ever wanted to see a little bit more of this, more of the details, the tool itself allows you to go ahead and look at perhaps different notations. So this particular notation is Barker notation, but if we use Bachman notation, for example, we would actually see the data types. But in all honesty, what Barker notation is it's easier to teach from. So that's why a lot of us use that when we're teaching. But a lot of times what we do afterwards, after a while, is we end up using more of the IEEE kind of notation. But anyway, for now, I'm gonna stay with Barker. All right. So in relational database theory, every entity, which is what these are, a student is an entity, a course is an entity, should have something that uniquely identifies it. Last name doesn't uniquely identify anybody. The first name doesn't uniquely identify. The full address doesn't uniquely identify, and the GPA, which might not even be populated, doesn't uniquely identify. No particular combination of these things uniquely identifies a student. We need to put in a unique identifier. So for that, we're going to go in here, we're going to click the plus, and we're going to create another attribute, which I'm just going to call student ID. And I don't know why I went uppercase here, but anyway, I just did. So student ID. And what is the student ID? Well, this is going to be a straight integer. And it's going to be the primary unique identifier. Now, notice what happens in mandatory when I click on primary. You cannot have an optional unique identifier. Now, the only other thing that I don't like about this, I'm going to go quick and apply. There's nothing magic here about this, but most people would prefer the unique identifiers to be at the top. So you can move it up to the top if you want to, and I can go OK. So now I got students, and there's a special hash in front of it. This is basically meaning that the student ID is the unique identifier. We're going to do the same thing with courses. I'm going to create a new one here. I'm going to call it course ID. Again, I'm not sure what I'm doing with the case. Oops, going to go down, make it an integer, and make it the unique identifier, and bring it up, and go OK. So now I've got myself entities, and I've got myself unique identifiers. Again, it doesn't necessarily have to be one column. Like, for example, if it turned out that course ID was also the unique identifier, well, what happened is I'd end up with two things that together make it the unique identifier. Now, course name is not, so we're going to take that off. All right, good deal. So we got ourselves some entities. The other thing we need to do is decide what is the cardinality behind this. And I'm sure you guys have totally forgotten what that means, but cardinality is a one-to-many, one-to-one, or many-to-many relationship. So when you think about you guys, a student, if a student had a one-to-one relationship with a course, what that would mean is that every student was only in one course, and every course only had one student. That is not correct, obviously. Many of you might be tempted to say that courses have a one-to-many with students. So one course can have many students. But what that would mean, and let me just do that here. What that would mean is that courses may have one or more students, but a student must be in a course. So when I'm saying may and must, it's these dashed lines and solid. So course may have one or more students. So it's effectively saying courses may have zero, or courses will have zero to any number, but it's just a different way of saying the same thing. You can either say courses have zero to many, or in this case, the optionality is in the line here. Courses may have one or more students. A student must, solid, student must have must be in only one course. Now, that sucks because I know many of you are in many courses. So in fact, that's not the right relationship to pick for this. So let's just get rid of it. I can click on it and click my delete key and just purge it. So this is truly a many-to-many, which is typically defined as an M to N. Now, normally what I'd want to do is I'd want to pick from parent to child. When it was actually a one-to-many, a course could have many students. Courses would be the parent, students would be the child. In this case, though, who's the parent of a many-to-many? And there really isn't any. So what I'm going to do is I'm just going to do the other thing where I consider entities that exist outside the system are parents to entities within the system. You know what? It's just whatever. But I'm telling you right now that if the database disappeared, students would still exist. Courses would not. Courses exist within the system. So I'm going to go this guy to this guy. Now, a quick word about the interface. What I did is I did a quick click, and now my finger isn't even on the button. And I kind of consider this a harpoon. It's sort of stuck in here. Notice I didn't click on any particular column. I just clicked in the blue space, and now I'm going to go over here, and I'm going to click in the blue space over here. And we're going to give it a name in a minute, but I want you to see what it did. So students may be in one or more courses, but to be a course, it must have one or more students. And we're going to have to probably change that in a minute. But before we do, we really should think of a good name for this relation, because relation 2 is a bad name. Now, if you don't know any better, one way to do this would be to go student courses, right? Now, when you're faced sometimes with entities that have really horrible names, or you just simply don't understand the logic, it's not a bad idea to put the two tables or two entities together and separate them by an underscore. But we actually know what this is. What is it called when you have a bunch of students attached to a bunch of courses? It's really the enrollment, right? That would be probably a better name. I'm going to go okay. Now, the other thing we're going to do here is we're going to say, okay, do I agree with the optionality part? I do agree that a student certainly might not be in any courses. For example, you could have a term off. I know for my master's, I actually took like several years off in between the first course and the last course because I had a job that made me travel 100% of the time. So for basically 3.5 years, I wasn't able to take any courses. But what about this? Can a course exist without students? You might be tempted to say, sure it can, but that's not really good because when we have courses right now that are being planned for the next few terms and enrollment hasn't even started yet. So we definitely do have courses without students that exist. So what we're going to do is we're going to go into this relationship and we're going to check on the optionality part. And I'm going to basically say that in this case, for courses, this is optional. Courses, the target is optional. Target optional. And now the whole thing is optional. Now this is an awesome relationship diagram, and you know, again, typically you put the parent to the left, child to the right, or parent on the top, child on the bottom. That's the kind of thing that you do here. But this is not implementable into a database. We couldn't actually code this. We need to go into the next level. We need to go to a relational model. We need to engineer this to a relational model. So I'm going to click on engineer. And honestly, when you do this yourself, feel free to look around. But right now I'm just going to click engineer at the bottom. And something magical happened. And let's make you bigger. And actually, let's make you smaller for a second and tell you what, I'm going to put you back to this. All right. And I'm going to put you back. All right. So hopefully what you're seeing at this point, I got 2 blue things and I got 3 yellow things. Now the blue things are entities. The yellow things are actually tables. Now when you see things like this happening, like see how I can't see everything, feel free to expand, and make it look nicer. So you can actually see what's actually in here. There you go. That's cool. All right, we're going to do that. And are we good here? All right. So it's a different notation. First of all, I want you to notice that certainly the asterisks still mean the same thing. They still mean mandatory. P means primary key. That's a primary unique identifier. Here's P primary key. But notice that this line that associated a many-to-many, that became, so this line that associated the many-to-many, that became an associative entity between, or an associative table, I should say, between the 2 tables. So what's happening now is that this enrollment is the table that tells me what students are in what courses. Now, a lot of times when I'm trying to explain this on whiteboards, I'll usually have sort of a quick little example here. So just as an example here, in the students table, if I got basically a student number 1 and the name is Grant for the student. And then I've got another student here, 2, which is basically Bill, okay? And then I've got courses, and I've got a course out here called CCIS 200, which is systems analysis, and a course ISTC 300, which happens to be database. So these 2 rows are instances of a student. These 2 rows are instances of a course. How can I tell which student is in which course? Well, in the enrollment, what I've got is I basically say if Grant is in both those courses, there'll be 1 row there that's got my unique identifier, and then the unique identifier, CCIS 200, the unique identifier of one of the courses, I'll also have one row for me with the unique identifier of the other course. If Bill is only in the systems analysis class, then we'll see Bill is in the systems analysis class. And what you'll see is that this data set associates the two other data sets. Okay, and so that's why many times we call this thing an associative table. Another thing we call it is a bridging table, because notice how it sort of bridges the two. Another thing that sometimes people call these things is an XREF. So what you'll see sometimes is the table will actually have a name, something like that, with the word XREF behind it, meaning cross-reference, right? So you'll actually see that being called that. Oh man, I forgot it now. I got bridging, I got associative, I got cross-reference. Oh well, I can't remember. Anyway, but you'll hear different names for this particular table, and it's pretty important, this relationship. Notice, by the way, a student must, not so much must. Let me try that again. Actually, okay, yeah. One thing before I go anywhere with this, the enrollment record here. The enrollment record must have a student inside the students table and must have a course inside the course table, right? How can you tell that? What's going on is that we now actually have something called a foreign key. So student underscore student ID is a foreign key that points to that primary key. Courses underscore course ID is a foreign key that points to that primary key. So a primary key uniquely identifies a row. A foreign key is a value that, if it exists, will point to the primary key of a table. And so that's what you're seeing here. And I think, is that all I wanted to say about this? Yeah, that's pretty well all I wanted to say about this. There's basically your one-to-many and a one-to-many. All right, now one last thing about this. This tool obviously has some intelligence behind it. Well, the other thing that you can do with this tool, if you ever wanted to, you won't be asked to do this. But what you could do is, I just wanted you to see that this thing also has the ability to generate source code. And that's what makes it a CASE tool, computer-assisted software engineering. That's what makes it a CASE tool. So this thing actually can create the DDL, and it can create it for Oracle, it can create it for SQL Server, and it can create it for IBM's DB2. And to be honest, with the appropriate drivers, can create it for other ones as well. And so that's what's kind of cool about that. All right, I think that's all I really wanted to explain about this kind of data modeling. I wanted to take you through this example of student courses. You'll obviously have a similar thing to work on in your actual labs.